Charles, or what's the other name?
Locust.
Gay Locust, you must. Lozak. Gay Lozak, you must memorize the name. Charles law or Gay Lozak law. What's the law? V1 over T1 equal to V2 over T2, provided that what's constant? Hello? يا شباب لسه ما صحيتوا؟
N is constant,
Yes,
right?
yes.
Okay, N and P must be constant, and then you can simply calculate V2, which is equal to
V1 plus 2.
V1 T2 over T1, and you can calculate it very easily. Don't forget, T must be in Kelvin, not in C. Third law, you must memorize the name, as I said. Okay, give me the first scientist who related P with V. V1 P1 equal to what?
Boyle.
Boyle's law, yes. Boyle's. V1 P1 equal to V2 P2, and this is constant, N and T constant. Now the third law is Avogadro's law. Avogadro's law is relating V with N. So we have, this one is, V is proportional to N. So V1 over N1 equal to V2 over M2, and again, what are the constants?
And T.
T. T is the constant.
P
T
and
and P.
T constant. Is this clear? This is called now constant temperature and pressure. This is called Avogadro's law. Avogadro's law. Very important. All right. Now, when we have, one more thing. I also told you last time, don't forget this. If we have 1 mole of gas at STP, what's the volume of the gas?
22.4.
Yes, you must memorize this number very, very well. 1 mole of a gas at STP, volume is 22.4. What's STP stands for?
Standard temperature and pressure.
What is standard temperature and pressure? What's it? Standard temperature?
Temperature is 0.
Yes.
Pressure 1, temperature 0.
And pressure is 1 atmosphere.
Temperature 0 what?
Kelvin.
No, 0 Celsius or
Celsius.
273.15 Kelvin.
Kelvin.
Clear? And what's the pressure?
1 atmosphere.
1 atmosphere. You must memorize this. This is STP. I hope this is also clear. Very good. If we have an equation like this, I told you many times, when we have equation like this, right away, you know, and you know very well that if we have equation like this, we can relate things by mole. So we can say here 3 mole of hydrogen react with what?
1 mole.
1 mole of N2 and produce
2 mole of ammonia.
2 mole of ammonia. Exactly. All right. Now, if we apply Avogadro's law, which is if we have constant P, T constant, then we can say V1 over N1 equal to V2 over N2 equal to a V3 over N3 if we have what? If we have constant pressure and temperature, and we're going to apply Avogadro's law. So I can say if I have 3-liter hydrogen, then how many liters I'm going to have from nitrogen?
3.
No, 1 liter. Because
1.
here N is 3, and N here is 1, and the N here is N3 here is what? 2. So this must be 3 to 2 to 1 to 2. Right? And so in this reaction, I can relate things not only by mole, I also can relate things by liter. I can say 3 liter react with what? 1 liter of nitrogen and will produce how many liters of ammonia?
2 liter.
2 liters ammonia, NH3. Is this clear? Is this clear? I hope so. Good. Now, if I have 10 liters of hydrogen at constant P and T, in this reaction, if I have 10 liters of H2, then how many liters of nitrogen do I need to make the reaction complete? What should I do?
Multiply by 1 liter nitrogen
Over
3 liter hydrogen.
Exactly. And you have the answer 3.33 liter N2. Clear? And again, if I have 10 liters of hydrogen, how many NH3 I'm going to produce?
2.
2, 3.
Ammonia. 2 mole of ammonia. 2 liter of ammonia over.
Is this clear? I hope so. Good.
Yes.
Very quickly, if I have this reaction at constant, okay, here we have all the same temperature and pressure. What does that mean?
It's a constant.
Constant.
I can relate things by constant PT and P constant. So I can do Avogadro's law here. I can easily say here that 2 mole NO react with 1 mole O2 and give me 2 mole O2, right? What I can say also, 2 liter NO react with 1 liter O2 to make 2 liter NO2. All right? We combine 3.0 liter of NO with 1.5 liter of O2. Then how many liters of NO2 will be produced?
How much?
What? What's the answer?
How much? What did you say?
3.
I have 3 liter NO. How many liters NO2 I will produce?
3.
2.
1.5.
What's the relation?
multiply by
Multiply by 1, divide by 2.
2NO2
2
2
liter
liter in O2
divide by
2 liter.
the 2 liter of NO.
NO. This will go with this, and you have the answer as what?
6.
3.
6.
6 liter in O2.
Okay, let me ask you a very simple question. If I have 2NO plus O2 to give me 2NO2, if I have 6 liters of
Doctor,
yes,
why we don't take the oxygen?
I'll answer you right now. It's okay to take the, in this case, I'll answer you right away. If we have 6 liters in O and 4 liters O2, then how many liters of
3 liters ولا أساسا.
no, I don't want this. I want only no, if I have 6 liters
3
or
or 2.
no, I'll keep it 4 liters O2. All right, then how many liters of NO2 I'm going to produce? If I take 4 liters oxygen, how many liters NO2 I should produce?
2.
8.
8.
8. Yes, it should be 2 liter NO2 divided by 1 liter O2, and it should be 8 liter NO2. Am I going to produce 8 liter? Wrong.
Exactly.
If I take 6 liter NO, then how many liters NO2 I'm going to produce?
6.
6.
6.
So which one I'm going to produce?
6.
And the answer is 6 liter. Which one I'm going to produce? 8 or 6? Only
So we have
6.
to choose the
Why? Why is that? Because the NO2 in this case is what?
Limiting reactant.
Limiting. NO2 in this case, limiting reactant. You have to be careful, and that's somebody answer, why should I use this one or this one? You should use both of them. You should calculate for both of them, for O2 and for NO, and you should take the one which will give you less, not the one which will give you more. So in this case, I take this one because it is the limiting reactant. Good, very good. All right, now we can have combined gas law if we have constant N only. If we have constant N only, then we can apply this law. You don't have to memorize the law. It's actually PV equal to nRT. You should memorize. It's P1 V1 over T1 equal P2 V2 over T2. That is the everything here is you change the pressure, volume, and temperature, but you keep N constant. All right. Write this law: P1 V1 over T1 equal to P2 V2 over T2. Let's apply it to this question. A child, we have a balloon here. All right. Child have a balloon which he closed. Now, if you have this balloon closed, is N constant? Yes, it is constant. Why? Why is constant? Because
it's close.
the amount is the same, right? Okay, now a child released 6.25 helium balloon. So he has this balloon filled with helium gas, and of course everybody knows that helium gas is lower in density than air. When you put air in this balloon will go up. The volume of the balloon was 6.25 liter. So V1 equal to 6.25 liter. Okay, in the parking lot of assumed amusement park, the temperature was 28.5. So T1 equal to 28.50 degrees C. Okay, and the pressure is 757.2. So P1 was 757.2. Okay, and the balloon went up, risen up, and high altitude. The temperature was minus. The new temperature was T2. T2 is equal to minus 34.35. Okay, and the pressure was P2 was 366.4 milliliter Hg. All right, milliliter Hg, and the degree C and this degree C. Now, how can I find the V2? You can apply this law, right? Which is P1 V1 over T1 equal to P2 V2 over T2, or V2 equal to P1 V1 times T2 divided by P2 over T1. Don't forget to change the temperature to Kelvin. Change it to Kelvin. But the pressure, don't do anything with it. Why? Because this unit will cancel with this unit. You don't have to change it to atmosphere or anything. Clear? Okay, give me an answer quickly.
10.23.
10.23.
10 point. V2 equal to what? 10.23 liters. Excellent. All right, that's what I'm trying to tell you. You'd have to change the temperature to Kelvin. Change to Kelvin. And this one change to Kelvin. But the pressure, you don't have to do anything with it. Why? Because when you divide this number by this number, the unit will go away. The volume and millimeter Hg with millimeter Hg will go away. If it's atmosphere with atmosphere, keep it as atmosphere with atmosphere, or any number. Even if it is Pascal with Pascal, keep it as it is. Clear?
Doctor,
Yes.
can we use V1 over T1 equal to V2 over T2 to solve this question?
No. Well, how about the pressure? The pressure change here.
Okay.
Everything changed. Volume, temperature, and pressure changed. We have new temperature, new pressure, and new volume. So you cannot apply Boyle's law or Charles' law or Avogadro's law. There is another one which is combined. Now, we know the law PV equal to nRT. What's this law?
The ideal gas equation.
Ideal. You have to memorize the name. Ideal gas law. What's the unit for P?
Atmospheric pressure.
atmosphere? What's the unit for volume?
liter,
Liter. What's the unit for N?
mole,
Mole. What's the unit for T?
Kelvin,
Kelvin. What's the unit for R? What? Atmosphere, liter divided by
Mole, Kelvin.
oh, Kelvin. You don't have to memorize the number. It's available in your periodic table. But what's the value of G of R? Clear? You don't have to memorize this number. It's available. If you have periodic table, look at your periodic table that I gave you. We always give you the value for R. Is this clear? Good. Now, when you take N over V from this equation, if you take N over V, what's this equal to?
V over
It is
molar.
It is N over V. It must be from the equation. It's easy. P over RT. Like this one. Good. Now, what is N? Number of mole. When you multiply N by the molar mass, what do you get? If you have 1 mole of oxygen gas, then what's the mass of oxygen gas?
1 mole times the molar mass.
It's 1 mole O2, and what should I write at the top?
32.
32 gram O2, right? And this, what did you do? You multiply by the molar mass. Now, if you multiply the molar mass by N, what are you going to get? The mass in gram. Now, if you multiply M by N, this will give you mass. Mass over volume is equal to what?
Density.
The density. So you can calculate. What did I do with this equation? I multiply both sides by molar mass in gram, and I have a density which is equal to P, pressure, times molar mass in gram divided by RT. And then you can calculate the molar mass. So if I ask you to find the density of any gas, you should, of course, I don't want you to memorize this equation. I want you to memorize this equation, which is the ideal gas law, but you should be able to change it to density very easily. Is this clear? Also, if I want to calculate only the molar mass of any gas in gram, what's this equal to? I need help.
It's DRT.
DRT divided by
P.
Pressure.
P, exactly. Fantastic. So what's D?
The density.
Density, what's the unit for density?
Kilogram per cube.
Gram per liter.
Milli.
Don't forget the volume was in liter, and the density must be in gram per liter. If it's gram per milliliter, you have to change it to liter. Okay? What is T? What's the unit for T?
Kelvin.
Kelvin. And P?
Atmospheric pressure.
Atmosphere, exactly. I want you, as I said, I don't want you to memorize this equation. I want you to be able to derive them. You should be able to find them. Here, carbon dioxide used as fire extinguisher. You know what's fire extinguisher? To kill fire, to put the fire off. Okay. The density is higher than water, higher than air. if the density, find the density of carbon dioxide gas. Find the density. Okay, as I said, I don't want you to memorize the equation. I want you to memorize PV equal to nRT. What's the density of CO2 at room temperature? 25. What's the equation that I should use? I should use what? N over V equal to what? P over RT. And then what should I do?
Multiply both sides by molar mass.
And what are you going to get?
PM D equals PM over RT.
RT. Good. Let's do this calculation very quickly. You have the mass of CO2, it's 44.01. So you have this one, gram per mole. And you have the pressure, 1 atmosphere. All right. And the temperature is 25. Calculate density quickly. Hello.
$1.8.
No, it must be wrong. Oh, no, 1.8 maybe, yeah. Let me see. Yeah, maybe, I don't know. So what's the density?
1.8.
Exactly. What I want to say, it must be higher than this number. Why I'm saying it's higher? Because we use it as fire extinguisher. What do you mean by fire extinguisher? It will make the fire go away. How? Because it's higher than air. Yes, the density is 1.8 gram per liter. Don't forget gram per liter. So it is higher in density than air. So if there is a fire here, which is a fire, the fire needs oxygen. But if you put CO2 gas, the CO2 will come and become lower here, all CO2 gas, and the oxygen will be far away from the fire, and the fire will go away. Is this clear? That's why we need to use something which have higher density than air to make the oxygen goes away and kill the fire. Good. Now, when we have any equation, as we said here, we can relate things by what? By mole. So what can we see when we have this equation? What can we say under this equation right away? That we need what?
2 mole.
2 mole CO react with
1 mole O2.
1 mole.
2 mole O2, and it will give me 2 mole. Right? Or at constant pressure and temperature, I can relate things by another way. What is it?
Liter.
2 liter CO will react with what?
1 liter.
1 liter O2 to give me 2 liter CO2. I can relate things by this. All right? Now, if I have solid and gas, I can only relate things by what? By only mole. What should I say here? 2 mole Na react with what?
1 mole of CO.
1 mole Cl2 to give me 2 mole NaCl. Can I relate things by liters?
No.
Why? Because it's not gases. I can relate things by liter if it is only gases. and if there is constant temperature and pressure. Is this clear? Good. All right, let's do this equation. Sodium peroxide is used to remove carbon dioxide from the air supply in spacecraft. So in spacecraft, you know, ايش يسمونها بالعربي
مكوك الفضاء.
المكوك, yes. They use Na2O2 to remove CO2 in this reaction, like this. All right. See, there is gas here, but this is solid. Okay. By reacting with CO2 in air to produce this, the volume in liter of CO2 at STP will react with, calculate the volume of CO2 at STP that will react with 1 kilogram. 1 kilogram. So I have 1 kilogram. I don't like gram. Always I want to make it right away. 1,000 gram Na2O2. How many grams of CO2 I should have to react with it?
1,000.
No. So what's the first thing you'll do? Must say you should find what's the mass of Na2O2. What's the mass of Na2O2? Go to your periodic table quickly. 1 mole Na2O2 give you how many grams from the periodic table?
44.2.
No, Na2O2.
22.
The mass of Na is 23, and the mass of O2 is 16. That is 39.
55.
Times 2.
77.98.
Yes.
78.
77.98 gram Na2O2. I got this number from periodic table. This will go with this. Now I can relate mole, 2 mole Na2O2 will give me how many moles of CO2?
2.
2 mole CO2. And now I will stop here. Give me the number of moles quickly.
12.8.
12.82.
82 mole CO2. Good. I have the number of moles at STP. What's the volume? 12.82 mole multiplied by 0.0821. What's this? What's this number? 0.0821.
Gas constant.
Gas constant. And then what's the temperature?
Zero Celsius.
Which is what?
273.
Point
15.
1.5. All of this divide by what?
1.
1 atmosphere, because it is STP. Quickly, give me what's the volume?
287.
287. 287.4 liter. Is this clear? I hope so. I hope so. Good. Okay. Also, we can do a change. If we have constant volume and temperature, we can make N equal to P times V over RT, or the change, you know, what's this? When we draw things like this, what does that mean? Change in what?
Delta N. Moles.
And moles.
Change in moles. And what's delta P?
change in pressure.
Pressure. If we have constant volume and temperature, then we can apply also this equation. Good. Okay. Now another air verification is used as scrubber in where we have CO2 coming out of factories. Okay, if we have this equation, okay, the pressure dropped. Okay, we have the volume, it's constant, it's 2.5 times 10 to the power 5, and the temperature is room temperature at 25 degrees C. So the volume is, this is the volume and this is temperature, all right, and we have the pressure is dropped from this number to this number. Okay, then what's the drop in the amount of the of CO2? All right, so can you calculate delta P? What's delta P? This is P1, this is P2 or P1, and this is P2. What's delta P? (0.9970) minus 0. What?
9.891.
Give me an answer.
7.9 multiplied by 10 to the power minus 3.
7.9 times 10 to the power minus 3 atmosphere. What's delta N?
هذا المطلوب.
Delta N equal to delta P times P over RT. So what's delta N? Delta P times, what's the volume? 2.5 times 10 to the power 5 liters times over what?
25.
0821 times,
Change it to Kelvin.
change it to Kelvin. 25 plus 273 is 298.15. And you have the answer. What's delta N?
74.55.
74?
80.68.
80 points.
81.
6. 81, yes. It is 80.6 or 81, exactly. So this is how you do this problem. Good. Now, you know the airbag that you use in your, la samahallah, if there is an accident, the airbag is full, or they put in NaN3, which is called sodium azide. That is what's available in the airbag that you have. When you have, la samahallah, accident, what will happen? The sodium azide, which is solid, will become gas of nitrogen like this, and the airbag in the car will start blowing up, and it will become big. It is according to this equation. That's what we put in our or in the car, the sodium azide. Sodium azide. All right, you should know this. It's available, and we are using it in our cars, everybody. Now, a typical driver's side airbag contains 50 grams of NaN3. Determine the volume of N2 gas that would be generated. La samahallah, if there is an accident, you have the air coming out. How many liters of air will come out. If the temperature, of course, in an accident, the temperature will be high, and that's why the temperature become 85 degrees C, and assume that the pressure is 1 atmosphere. If the pressure is 1 atmosphere and the temperature is 85, then what will be the volume of the gas? As I said, you have 50 gram in a N3. Don't forget, the sodium mass is about 23. Nitrogen mass is 14.01. So how can I solve? What should I do first?
Find the moles.
Find the number of moles. How?
1 mole over
1 mole.
the molar mass.
3. What's the molar mass?
65.02.
65.02 gram in 3. This will go away with this one. Good. Then how many moles of N2 I'm going to produce?
0.769.
3 mole N2 will be produced from what? 2 mole in 3. This will go with this away. Now what's the answer?
1.15.
1.15 mole in 2. Good. Then what's the volume? I have the number of moles, I have temperature, and I have the pressure. What should I say? N over E. Give me an answer quickly. Come on.
33.9.
Exactly. It is 33.9 liter into. I hope this is clear. And you can see 34 liters is a lot of volume. And that's why the air become, the airbag becomes so big. Good. Next, Dalton law. Dalton law of partial pressure and mole fraction. Dalton law of partial pressure says that if you have gas, different gases like this, gas in a container, let's assume that we have gases in the container. Let's assume that we have one gas which is called A, and the other one is called B. Then what's the volume? Let's assume that the volume of this box is equal to our volume box. What's the volume of A? What's the volume of gas A only?
Volume of box minus volume of B.
No, it's the volume of the box, the whole box, because it's everywhere. Clear? What's the volume of B?
Volume of the box.
It's the volume of the box also. No difference. Clear? All right.
Clear.
What's the temperature of A? Temperature of the box.
Temperature of the box.
What's the temperature of B?
The same temperature of box.
Temperature of the box. Yes, there is no change. All right. Now, Dalton law says that the pressure of the total pressure, is equal to the pressure of A plus the pressure pressure of B. That is called Dalton law. I'll make it more clear by saying that P total, PT, equal to summation of the pressure of I, which is I any gas, all the gases. Is this clear?
Doctor?
This means this is called Dalton law. Dalton law is very easy. This is called the name. You must memorize the name. Dalton law. What is the Dalton law? It says that the P total is actually the pressure of each component by itself. Why? Because it's the same volume, it's the same temperature, and this, the only difference is only the pressure, and this must be related to the number of moles. And that's why I will also introduce to you now mole fraction. Mole fraction, I will introduce by saying the mole fraction is X. X, the mole fraction, is equal to number of moles of A divided by number of mole total. This is called the mole fraction. Mole fraction. And this way, P of A equal to the mole fraction of A times P total. That's another way to say Dalton law. Dalton law. Is this clear? Okay, I will give you everything. Dalton law says that P total is equal to summation of PI. This means the pressure of each component in the gas. So if we have a container, as I said, and we have three kinds of gases, A, B, B, and C, for example, all right, then the P total, PT, is equal to P1 plus P2 plus P3, which is, I call them here A, B, and C, same thing. All right, this is the first way to look at Dalton law. You have to memorize this. Why? As I said, because the volume is the same, because they are on the same volume, all of them, and the temperature is the same, and R, of course, is constant. So PI must be proportional to Ni, which is the number of moles. PI must be proportional to Ni, because V and T and of course R are constant. Okay. Now let's assume that we have 1 liter vessel contain 0.215 mole N2 gas and 0.118 mole H2 at 25 degrees C. All right, what will be the total pressure? Can you find the P total?
Yes. Add the 2 moles.
Yes.
No.
No. Actually, as I said, P total equal, let me go back to this, is equal to P1, PA plus PB plus PC. We can also say N total, because it's proportional like this, N total equal to what? N what?
NA plus NB plus NC.
E plus NC. Is this clear?
Yes.
So this is Dalton law, and this is related to Dalton law. Related to Dalton law. Let's solve this problem. We have the volume The volume is 1 liter. This is the volume. We have the temperature, which is 25.5 degrees C. Of course, you have to change it to what? To Kelvin.
Kelvin.
Good. So I want now what's in total. I need help.
The H2 plus the mole of
2.5 plus
0.0118.
0.0118 exactly. All right. And what is it going to be? Give me an answer.
0.22.
6.8.
6.8 mole in total. Good. Can you calculate P total now?
Yes.
And total
0.2268.
RT divided by V. What is it?
5.56.
5 point. What is it?
0.586.
56 exactly. Excellent. Very good. So P total equal to 5.56. Let's do another problem here. What is the P of hydrogen only or nitrogen only? I want to calculate P.
Sir,
Yes.
PT it's 5.56 Pascal.
No, atmosphere. Everything is
That's
atmosphere.
pressure.
PV equal to nRT atmosphere.
Okay.
When you use PV equal to nRT, everything in atmosphere. What's the pressure of nitrogen only? Calculate it, give me an answer quickly.
5.27.
Thank you, 5.27 atmosphere. What's the pressure of hydrogen only? Do it quickly. 0.029 atmosphere. Good. Add these together.
Will be the same, the 5.56.
5.56 atmosphere. Which law you are doing?
Dalton law.
Dalton law. P total equal to pressure of each component. I hope this is clear. Good. As I said, don't forget, what's this called?
Mole fraction.
Mole fraction. Mole fraction. All right? Okay, let's go to this problem. This problem. What's the mole fraction of hydrogen? Of N2, let's say. What's the mole fraction in this case?
0.215
0.215 divided by what?
divide 0.2268.
0.2 what? I need help.
2268.
2268. 2268. Exactly. Give me an answer.
.95.
95. And what's the unit?
No unit.
No unit, exactly. Mole will go with mole. Very good. So there is no unit. Very good. Now, I want you to tell me what's the pressure of nitrogen only based on this. It's equal to the mole fraction of nitrogen times P total. This is another way to look at Dalton law. What's Pn in this case? Use this number and mole fraction and tell me what's the pressure. 0.95 multiplied by the P total 5.6. What are you going to get?
5.27.
5.27.
So yes, you can go this. Very important, you must memorize and you have to know how to get the mole fraction, and you can calculate the mole fraction of anything like this way. Calculate the mole fraction of NO in 10-liter gas cylinder at room temperature. So we have the volume, we have the temperature that contain 6.022 mole N2, in which the total pressure is 14.75. If you have P total is equal to 14.75. What can you calculate? Can you calculate in total? What is in total? Hello?
PT multiplied by
0.75 times
N
10 liter. What? Yes. Yes. Over what?
0.082
0.0821 multiplied by
298.15.
298.15. Okay, give me an answer quickly.
It is 6.03.
6 point
03.
0, actually 2 according to, yeah, 2.3, yeah, 2.9. All right, 2.9. Very good. Then what's the mole fraction of N2? Is it N2 or N? Yeah. What's the mole fraction of N2? We have 6.22 of N2. Yes, 6.022 divided by what?
By 60209.
And you have an answer. What's the answer?
1.03.
It cannot be 1.
0.998.
What?
0.999.
Yes, 0.999. Exactly. It cannot be 1. If you have it 1, then you are wrong. It must be less than 1. That's the meaning of fraction. Fraction means less than 1. You have to know this. So if your answer is 1, then you are wrong. Then right away, what's the mole fraction of NO? NO. Must be what? 1 minus 0.999. And what's it going to be?
0.001.
Exactly. So we can find the mole fraction of anything like this. Is this clear? I hope so. Good. Now, when we collect gas over water, then there will be always in this water here pressure of water. So the pressure of water is always there. That's why we have to know what's the pressure of water. The pressure of water is always constant at a certain temperature. So if you are doing experiment in which you collect gas here, any gas, like for example, we are doing experiment like this, we're reacting KClO3 to collect O2 in this tube. So what will be the gases available here? There will be PO2, which we reduce by the experiment, but there will be also H2O gas because of the water. It comes from the water. That's why the P total equal the pressure of O2 plus the pressure of H2O. Always, whenever you collect gas over water, there will be some gas coming from the water. Now, the pressure of the water is always constant at a certain temperature. So what's the pressure of water at 25 degrees centigrade?
633.
No, 23.8 at this temperature. At 30 degree, what is it going to be? 31.8. At 35, this number and this number and this number. Don't memorize any of this number. I will give it to you, but I want to tell you that the pressure is constant at a certain temperature. Is this clear?
Yes.
Good. Calcium metal react with water to produce hydrogen. So here we are producing hydrogen over water. So this must be the total pressure equal to what? Pressure of what?
Water plus hydrogen.
Plus hydrogen. What's the pressure of water without even thinking? The pressure was collected at 25 degrees C.
23.
So, the pressure of water.
23.8.
You have to go back to the table and find what's the pressure of water at this temperature.
23.8.
Don't know what it is. I find it from here. Okay, 23.8. So can you change 23.8 torr to atmosphere? Yes.
Yes.
Divide by what?
76.
76. Exactly. Give me an answer. So you have the P total now. The P total here is 0.967. What's the pressure of water only? From here.
0.03.
0.03. Is it 3?
330.
0.013. 313. Yes, exactly. Atmosphere. So what's the pressure of hydrogen only? What?
0.928.
928. Exactly. Now, can you calculate what's N of hydrogen? PV over RT. This is the pressure of hydrogen only. So it is 0.928 multiplied by what? Times what? 0.525 liter divided by what? R, which is 0.0821 times temperature. What's the temperature?
298.15.
Yes, and you have the answer. Give me how many moles of H2?
.02.
Actually, yes. 2.01 times 10 to the power minus 2 moles H2. Exactly. So, as I said here, we have to, whenever you calculate things over water, look for the pressure of water. You can look, see, it's given to you here. The partial pressure of water is 23.8 atmosphere. Change it to pressure of water atmosphere and then do your calculation. Good. All right.
She said you're dancing in the movie.
Yeah, Shabab. Okay, next. Let's go to the last subject in this chapter, which is the kinetic theory of gas. Kinetic theory of gases. All right. The gas is composed of particles. They are relatively large distance. The volume of individual gas, when we have any volume, we consider the volume of the container is the volume of the container. What's the volume of the gases only? It's so small that we can consider the volume of the gas in any container is what? Volume of only the gas is approximately equal to 0. This means the gas is not occupying any volume. It's exactly like this. You can see I put small dots that the volume of these dots are almost 0. And that's why we consider that the volume is the volume of the container and the volume of the gas itself is 0. Okay, gas are always moving. They're always moving in random. So when you have any container, the gas is moving like this by itself and hit the wall and come back. When it hits the wall, that's what's caused the pressure. So what caused the pressure? The pressure is caused because of hitting the wall of container. Pressure is because of hitting wall of the container. All right. Now we consider that when the gas are like this, there is no attraction or repulsion between them. They don't see each other. The gas molecules are very far from each other and they don't see each other. That's also important. Okay, there is no attractive or repulsive forces between them. Each one is moving by itself. Okay, the most important thing is the energy. The energy of the gas is related to temperature. So if you increase the temperature, what will happen to the energy? The energy will increase. The energy will increase with the temperature. Okay, or actually I want you to memorize this equation, which is not here. E equal to 3 over 2 RT. I want you to write this equation and memorize it. E equal to 3 over T RT. R, we know, everybody knows what's T. Hello? Temperature. What?
In Kelvin.
Kelvin. What's R?
Gas
constant.
But this time, we're not going to use the 0.0821, that is liter atmosphere divided by mole Kelvin. No, we're going to use another R, which is the same R, but with different units, and that's why this will be 8.31 joule per mole Kelvin. And that's why don't memorize the number. As I said, it's available for you in the periodic table. But what I want to say that what's the unit that we use for energy?
Joule.
And that's why when I want to calculate energy, I will use the R, which is related to energy, which is R equal to 8.31 joule mole Kelvin. All right. Now, the speed of each molecule, we're going to consider how fast each molecule is moving at different speed. Let's assume that we have, let's go back to this one. Each molecule here is moving at different speed. Maybe this one speed is U1, this one is U2, this one is U3. We calculate what's called root mean square is this speed, which is the square of the speed of each one divided by the number of molecules. This is all what I want you to know in this equation, that what we calculate is the square of speed of each molecule, and then we divide it by the number of molecules, and this is called U squared. When we take the square root of U square, this is called root mean square, and from now on we will call this speed URMS. I want you to memorize this. What is this? Give me the name of this thing. It is the speed of root mean square speed. root mean square speed. Is this clear? Okay, I want you to say it.
Doctor,
Yes.
so is it like the average U square?
Average, exactly, it's the average. But it's not any average, it's root mean square average speed. All right?
Okay.
Okay, say that again. Root mean square. That's what we are going to calculate for these molecules. Good? Next. Now we can calculate the root mean square. I'm not going to tell you how are we going to do it, but I want you to memorize this equation and memorize it very, 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 very well. That's the root mean square, which is equal to square root of 3RT over M. And I want to tell you now, the root mean square, we're going to use if it's speed, then what's the unit, the SI unit for speed?
Meter per second?
Exactly. It's meter per second. What's the unit for R, since it's energy?
Joule.
As I said, it's 8.31 joule per Kelvin mole.
Oh.
Exactly. What's T? What's the unit for T?
Kelvin.
Kelvin. What's the unit for M? What's this M, by the way?
Molar mass?
Molar
mass. But the unit, since we want SI unit, what's the unit for SI unit?
kilogram.
Gram. Kilogram. Is this clear? So,
Yes.
if I want to calculate the root mean square for O2 gas, what are you going to tell me? It's equal to what? 3 times what?
8.31.
8.31 times what? Let's assume that T at 25 degrees C.
298.5.
298.15 divided by what? 2 times what? 20 minus 3 to make it kilogram. Is this clear?
Yes.
Very quickly tell me what's the answer.
Doctor.
What?
Doctor. I have a question.
$481.
Yes, 400.
400?
81.96.
481.96 meter per second? Maybe, I don't know, but maybe you're right. All right, and I'll stop here. I will very quickly now take the attendance, so please bear with me.
Doctor, I have a question.
Yes, just a second. Let me take the attendance first, and then I will. See, now. Okay, again, as usual, I'm going to send you now the okay, I already sent you now the link. Very quickly, You have 1 minute. You have to.
Close دكتور.
What?
I think
close يا دكتور ما تشون.
close.
close يا دكتور close.
كلوز يا دكتور كلوز.
حدثوا الصفحة بتشتغل معكم.
اشتغلت يا شباب اشتغلت.
اشتغلت الآن. Okay. Are you done?
No دكتور wait.
Okay, go ahead.
دكتور هل الرابط جديد ولا القديم؟
نعم. الجديد هو المكتوب عليه 21 سبتمبر بس don't worry about it. Just go to the link that I just sent you on Microsoft Teams and put يعني check it as usual. I hope it's done. I'm going to stop now.
Doctor, I have a question.
Yes.
For this class, the late is 10 or 15 minutes?
What?
For this class, 1 hour and 15 minutes. The late from 10 to from 0 to 10 or 0 to 15 minutes.
إيه؟
يعني التأخير عند في الحصة ذي كم أكثر حد 10 ولا 15 دقيقة؟
ما حددت أنا والله ما في